So we are on page 5682, which is on page 55. Of these four, are we going to do? I don't think there's any HL on this page, so that's why HL is not listed here. So these are just these four congruence theorems. And so we have to decide, based on what we have marked and what we know, which one of these four theorems can we use, okay? Because we don't have labels or anything like that, we don't have to identify pieces, and we don't have to name the triangles that are congruent. We just have to identify which congruence statement we can use, okay? All right, so let's start with number one. What other piece of information do we know about number one that's not already marked? The line in the middle. Yep. Okay, whenever we see two triangles share a side, then we know that those triangles have the same length, right? That side is shared. If I were to separate those two triangles, that side would be the same on both of those triangles, right? Right now, we're trying to prove the triangle on top is congruent to the triangle on bottom, okay? So right now, do I have three pieces marked on those two triangles? Yeah, okay? So if I pay attention to the pieces, okay? Let's say we started with this side. Side, side, angle. Do we have a side, side angle theorem? No, okay? This one is angle, angle, side, side. Oh, well, we don't want that. No angle, side, side for me, thank you, right? We never want to write angle, side, side out. That would be bad news. Mr. Ruda might get mad at you if you wrote angle, side, side out. Ben?
Yeah.
Well, how come?
Because it's spelled ass.
You would never do anything like that, right, Ben?
No.
No, I didn't think so. Okay? Yeah, we don't want angle, side, side. Okay? And so, is there another piece here that I can name congruent? Is there anything else I can prove congruent? We don't really know anything else, right? So we have three pieces. Are these three pieces enough? Can we use any of those four theorems? No. Okay. So we're going to say not congruent. Okay. Okay, number two, very similar to number one. Do they have a shared side? Yeah, they have a side that's shared, right? This side right here is shared between those two triangles. Okay? That's what it means to be a shared side. That side is the same on both of those triangles. Okay? That's almost like a given piece of information, but we want to go ahead and mark it so we know that they are congruent. So what we have now is we have an angle, we have a side, and then we have an angle. Is angle, side, angle one of my theorems?
Yeah.
Yes. So that's what we use. Okay. Number three. Who wants to try number three? Side, side, side. How come, Berkeley? Okay, perfect. We don't have any angles, but we do have three sides, and three sides is perfect. All three sides are congruent. Okay, the third side is not marked, but we know it's congruent because they share. If they're separated, we can't use the reflexive property, but if they share a side, then we know it. Okay, number four. Okay, who said angle, side, angle? Okay, how come, Landon?
The two, where the two triangles meet in the middle. Wait, which one are we on?
Yeah, number four.
Oh,
Where the two triangles meet, what do we know?
that's like where they're congruent.
Okay, how come? What do we call those two angles?
Vertical.
Vertical angles, yep. Okay, vertical angles is just like the reflexive property. We don't necessarily have to be given that information to know those two are congruent. And there we can look at our pieces and we have angle, side angle. That's it. Good. Okay, number 5. How many pieces do we have? 2. Okay. Do these two triangles have reflexive property? Do they share a side? They're separated, right? They can't share a side if they're separated. They also don't touch each other, so there's no vertical angles involved, okay? Is there any other sides I can prove? No. If two triangles are separated like this, you're not going to be able to prove anything unless something is told or given to me. So I can only use what is given to me, and right now 2 pieces is not enough, and so we would say these are not congruent. We only have 2 pieces. 2 pieces is not enough. Okay, number 6. A lot of times when people see the right angle, their first thought is HL, okay? Now, what I'm going to tell you about the HL theorem is just because I have a right angle doesn't mean I have to use the HL theorem. I can use the HL theorem, but if I'm going to use the HL theorem, I have to have a right angle, okay? But when I have a right angle, I could also use angle, side angle, or side angle, side as well. It's an angle, just like any other angle, okay? So don't immediately think you have to use the HL theorem when I have a 90-degree angle, even though I could. But on this one, I can't because if this is my 90, this is my hypotenuse, and I don't know if this side and this side are congruent. It's not marked, and I don't know it, okay? So because I don't know the hypotenuse, I can't use the HL theorem. Okay, but we talked about this one just a few minutes ago, okay? Close. Okay, it does have vertical angles. I'm with you there, okay? So what kind of piece would we have here? Angle, side, angle, okay? So we just have to be careful with the 2 pieces I have, okay? This one has 2 angles and a side, so we want to use angle, side, angle. Okay, if I had 2 sides and an angle, then we could use side, angle, side. Okay, number 7, how many pieces do we have? 3, okay? But then we have to determine if those 3 pieces are enough. Okay? So let's look at this one here. This is angle, side, side. Uh-oh, we said that one's the one we don't like, right? This one is side, angle, side. Side, angle, side is good, but is this one over here side, angle, side? No, okay? The angle would need to be right here. It has to be between the 2 angles, or the 2 sides, okay? This angle is not between the 2 sides. Over here it is. So this triangle is side, angle, side, but this one is not. They both have to be in that side, angle, side relationship, okay? So once again, this one is not congruent. 3 pieces is not always enough, guys, okay? So don't just assume because I have 3 pieces that it's going to be okay. Okay, number 8. Who wants to try number 8? Okay, we have all 3 sides congruent. All 3 sides are marked. There's no angles, so side, side, side. Okay, that's all there is to it. If all 3 sides are marked, we're in good shape. Okay, number 9, there's 2 pieces marked, but what additional piece is not marked that we already know? Vertical angles, okay? Vertical angles and the reflexive property are almost like they're given. We still got to mark it so we know they're congruent, but they're almost like given pieces of information. But they're usually not going to be marked. So we got to mark them to show they're congruent. So then I follow the path. Side, angle, side. Over here is side, angle, side. Both of these are in the same relationship, so just follow the pieces, right? If it's marked on the side of a triangle, it's a side. If it's marked on the inside of the triangle, then it's an angle. That's it. You got to decide, do I have a side or an angle? There's no other pieces to a triangle. You got sides, you got angles. Okay, number 10, what piece of information is not marked? Okay, and what do we call that? Reflexive property, right? So this piece is congruent to itself. The two triangles share that side. And so this would be another side, side, side. Okay? Any questions on any of those 10? Okay? Being able to identify it is huge, guys. Okay? And as we go for the next week or so, we're going to be seeing triangles like this over and over and over again. And now we have 5 different ways of proving triangles congruent. And so we got a lot of different things that we can use here. But then there's a lot of stuff to know. Okay? So being able to look at a triangle, seeing what I have, and seeing what else I need to get there is a really, really big part of what we're doing. Okay? So these are pretty straightforward because the markings are already there. We're going to do some today where the markings aren't there, but maybe we're provided some other information that maybe we can eventually get there. Okay? And today's going to be a lot of proofs. And we're trying to prove certain triangles are congruent. And so when I do a proof, then that pretty much tells me that these triangles are going to be congruent. I just got to determine why. And so we're going to list it out step by step on what we know. Okay? So here we go. First one here. As we've been doing all semester, whenever I do a proof, my first step is always given. Okay? So I'm just restating the given statement. And you can do those all on the same step. If it's not already marked, you would want to mark it at this point too, but both of these are already marked. These two are congruent, these two are parallel, and we just put an arrow on it, okay? So if it's not already marked, we got to mark it. Okay, we've seen triangles like this today already. If two triangles meet at a point, what do I know? Vertical angles, okay? Vertical angles is almost a go-to here. If the two triangles meet up at a point, then we're going to say they're vertical angles. But what's different here is that we are actually stating it out. On the ones that we did just a second ago, we just marked it and said, why are the triangles congruent? Here, we're proving it out, so we need statements. Can I call this angle, angle B? Is it okay to call it B? I can call this one angle D because D is the only angle, this is the only angle at D, right? But here we have two angles at B. So I can't just call this angle B because which angle are you talking about? Right? So we have to call it ABD. B has to be in the middle. Is congruent to EBC. And we said that those are vertical angles are always congruent. Okay, how many pieces right now are congruent? Is this side over here congruent? CE and AD, are these two congruent? What's this symbol right here telling me? Parallel. Okay, it's an arrow. It's not a tick mark, right? It's an arrow. Arrow means parallel. Parallel does not mean congruent. Parallel means they are parallel. That means they're never going to cross, okay? So those are not the same markings. That does not mean the same thing. So right now, how many pieces do we have marked as congruent? 2, okay? We have an angle and we have a side. I need one more piece. What we have not used yet, and the given information here is for a reason. We're going to use it in some shape or form, okay? So it's marked here that these two are parallel, and if I have parallel lines, what type of angles do I typically try to prove congruent? Alternate interior, okay? And I could use any of those pairs that we talked about way back when. Like when we talked about parallel lines way back when. We had alternate interior angles, we had corresponding angles, we had all kinds. When I do these, we're typically talking about alternate interior angles. Now, here's where you got to be careful. And I only say careful because of this. Are these two angles congruent? Are D and C congruent? Yeah. Okay. What about A and E? Are they congruent? Yeah. Okay. So does it matter which one I mark? No. I could actually mark them both. Okay. But I don't need both of them. I just need one of those pairs because I already have this one right here. Okay. So I don't necessarily need to do both, even though I could do both. Okay. And I'm going to show you why that matters here in just a second. So I'm going to say angle D is congruent to angle C. And we're going to say something like, if we have parallel lines, which we do, then alternate interior angles are congruent. Based on the markings that I have right now, what piece do we have right here? Bryson, what is that? What is this piece right here? What do we call that? Is it an angle or a side?
Angle.
Angle. What's this?
Side.
Side. What's this?
Angle.
Angle. So what did we just use?
Angle, side, angle.
Angle, side, angle. Okay? So now what we're going to do is we're going to take this statement down here. We're just going to rewrite it. Triangle ABD is congruent to triangle EBC by angle, side, angle. And that's my proof. Okay? Now, here's what I was going about just a few minutes ago. If I had marked A and E, because we said they were congruent, right? Then I would have had angle, angle, side. Would angle, angle, side been okay? Because we know these two are congruent, so then I could have done angle, angle, side, and those two would make angle, angle, side, right? So can I write my proof other ways? And sometimes I can. Sometimes there's maybe 2 or 3 different ways I could write my proof out. And they're not all going to be angle, side, angle. So I just showed you that on this proof we could have done angle, side, angle, or we could also do angle, angle, side. Both of those are correct. Okay, so there's really not one that's better than the other, okay, or easier than the other. It just kind of depends on the path that you go. Is there enough information? That's the key piece. That's the key part to what we're doing. So I just want you to understand that, like, you might see me do a proof one way, but if you disagree with it, ask me. And we can look at it and see if your proof is another way. Because I probably am not going to put every single possibility down on a key. Okay? On big ideas, I think it's a pretty straightforward, this is the only way to do it. But there will be some that there's more than one way to get there. Okay, let's look at another one. Okay, number 1. Angle S is congruent to angle U. RS is congruent to VU. All of that is given. Okay, always make sure that that information is marked on my picture. If it's not, we want it marked so we can see what we know and what else we need. So right now, how many pieces are marked on this picture? 2. And those are the 2 pieces that are given to me right here. Okay? They give me the 2, they mark the 2. So far we have 2. How many do I need? 3. Our goal is to get to 3 pieces, but it's got to be the right 3 pieces. Okay? So now, once again, we see something that we've seen about 5 times today. Okay? You're going to start seeing a lot of these things over and over and over again. Okay? It's going to become a little bit of a routine. What do we see in this picture that we have used over and over again? Vertical angles. The 2 triangles meet at a point, then they will always have vertical angles. The 2 angles that are congruent here are vertical. I don't need that piece of information to be given. Okay? So what would I call this angle right here? What's one way I could call this angle? RTS. Could I also call it STR? Would that be okay? Does it matter which letter I start with? No, but what does matter is that T is in the middle. So you can't call it like TSR, because that means this angle right here. T must be in the middle. So I could either call it RTS or STR. Neither way is more right than the other. So I'm going to say angle RTS is congruent to angle VTU, because vertical angles are congruent. Okay, I now have three pieces, and the reason why we want to mark it on our picture is so now I can look at the pieces that I have and see if that's enough. Okay, so some people asked me yesterday, how do I know if I start with an angle or a side? Well, you don't really always know. Okay, like if I started with my side here, this would be side angle angle, but we don't have a side angle angle. So what if I reversed it? What if I started with the angle and I went angle, angle, side? Do we have an angle, angle, side theorem? Yeah, that's one of my 5, right? Angle, angle, side is one of the 5 that we have. Okay, what statement am I going to put on number 3 now? Do we have to make up our own statement? No, what are we going to do? What are we going to put right here? The proof statement, right? We are now to the point where we're ready to prove. I'm moving this down here. The reason I'm telling you that is so you don't have to make up your own statement. You can just take that proof statement, move the whole thing down here. And then what we said was this is angle, angle, side. And that's my proof. Okay. What I would probably tell you is that 3 steps is probably the shortest proof that you're going to see today, because you're going to have given information. I'm going to need something else in there, some other additional step, and then my last statement is going to be my proof step. So your last statement is going to be one of your theorems. Angle, angle, side, side, angle, side, one of those theorems. Okay, 3 is probably as short as you're going to go. The one we did just a second ago was 4 steps. Okay, so probably going to need at least 3 steps to do these proofs. Some are going to be 4 or 5, some are going to be 3. All right. Let's rewrite our statements. AC and DC are congruent. Okay, what's the upside down T mean? Perpendicular. Okay, so those 2 sides are perpendicular to one another. Okay, so that's why in the picture they marked these as 90, right? They went ahead and marked it as 90, but we know that angle A is congruent to angle D. How come? They're both 90 degrees, okay? And we know they're 90 degrees because close.
Oh.
Definition of perpendicular, okay? Because we don't have 2 angles necessarily together that are making it 90, but it told me that ED was perpendicular to CD. And if it tells me that they are perpendicular, then I know it forms a. If 2 lines are perpendicular, they form a 90 degree. Okay, that's what the definition of perpendicular is, right? Same thing over here. AB and AC are perpendicular, so they form a 90 degree angle. That's why we can go ahead and put the 90 degree angle in there, but we need a statement that backs it up. Okay, we know what it means to be perpendicular, so we know that they're 90. Okay. Right now, do I have enough? How many pieces do I have marked so far? I got 2. 2 is not enough. I need one more piece. Do we see something that is a common theme today? Ryan, what do you think? Vertical angles again, right? These two angles are congruent. So we're going to say angle ACB is congruent to angle DCE by this point. We've probably seen that 8 times today. Okay, it's a common theme. Reflexive property, we saw that a ton of times yesterday. Okay, vertical angles and reflexive property are 2 that are going to be over and over and over again. Okay, almost like you're going to get tired of seeing them. But if they're there, that means it's a good thing because it's easier to prove pieces of information. Okay, so we need to know if we're going to be done. Okay, with the pieces that I have marked, is there enough to prove that these 2 triangles are congruent? Okay, Darsten, do I have enough?
Yes.
Okay, what theorem am I going to use?
I don't know.
I don't know. Hendricks, what do you think? Angle, side, angle. That's right. We got an angle, we got a side, we got an angle. Okay, we're just going to follow the path. And so when I write my proof statement, just copy this down. You can make up your own if you want to. That's not the only way it can be written, but why make up something when we got it provided to us, right? There's no reason to have to write our own out. And we have angle, side, angle. Okay, I want you to try this one on your own, okay? I'll come around and help out, okay? You guys do it, and we'll go over it, and then this is our last example for the day. But I want to see if you can write this one out. Yeah, it's good. Yeah, we'll try. Okay. So right now we have an angle and we have a side. Okay. So I need one more piece. Okay. What can I do when I have arrows here? Okay. So what 2 angles would we say are alternate angles? Okay, so because these are my 2 parallel lines, then I have to do an angle that is formed between those 2. So I would have to do like this angle here and this angle here. So I would call this one my angle AGH, and I would call this one FHG. So I would say those 2 are alternate.
It tasted alright, it's just, I sat there, I wanted to drink it, but then I had to wait for the ice, you know.
It tastes better now.
It was like blue, whenever we first got it. But you seem like toasted, like
Wait, what was the third one? Wait, what?
Look at Ben's.
Ben's
Oh.
small.
I put, I'll send it to your email, I put that symbol. But
Ben was drawing the seismic quakes in his phone.
just to help you work in class, you know, 'cause you're a little slow. What have you been doing for weights?
Huh?
What have you been doing for weights?
I don't know. He tells coach he's been benching, he's not benching. He just sits back there. The coach doesn't even pay attention. I was doing my own lift, like, he sits over there on his phone, like, he just sits over there on the desk like this. And I was doing my own lifts, and I'm over here like smacking the bar on the ground. He didn't even look up at all.
I just been wondering.
Just say Coach Warner. Mr. Warner said.
For, weights.
Okay. Right now, we know that these are 90-degree angles, okay? They're right angles. So in some cases, they're gonna ask you to come up with an additional step. I'm gonna show you probably like what big ideas would say here. I don't necessarily, like if you were writing this proof out, those two 90-degree angles, we know 90-degree angles are always congruent, but in some cases, big ideas may ask you to identify that angle F is congruent to angle K. We just need to say that they're congruent because right angles are always congruent. Okay. So that is just kind of like an additional step that I don't necessarily know if you need it because we know 90-degree angles are always congruent. Okay. But if it said they're acute angles, then we would have to identify that they're congruent because of whatever way we could do that. Okay, now, what other thing do these two triangles have that's not marked already? Yep. Okay. HG is congruent to HG because of the reflexive property. That's another one that's like almost a given. Okay? Is it wrong if I say GH instead? No, GH is the same as HG. You could even say HG is congruent to GH, and they may not be written exactly the same way. HG and GH are the exact same thing. Okay? So how you write it could be either way. And I'm going to mark it. Okay? So right now I have an angle and I have a side. I have two pieces. I need one more. Ryan, what do you think? Okay, except what do we, you're correct, except what do we have to do? Okay? So we just have to be really careful here. This angle and this angle are congruent. And the reason we have to use these two angles specifically is because of where the arrow is at. This angle must touch the parallel line with the reflexive side, okay? And same thing over here, parallel with the reflexive side. So it has to be these two angles. It cannot be these two because we don't know if the top and bottom are parallel. If we knew the top and bottom are parallel, I could do either pair, okay? So we have to use the side that is parallel. I also can't just call it angle H because Which angle H are you talking about? Are you talking about this H? Are you talking about this H? Or are you talking about the big H? There's 3 different angles at H. So you got to be more specific than just angle H. Okay, what would I call this guy over here? KGH. Would it be okay if I called it HGK? Yeah, order doesn't necessarily matter there, okay? As long as G is in the middle. That's the big one, okay? What kind of angles are those? Alternate interior, okay? So we're going to say if we have parallel lines. Why do I write this part first? Are these 2 alternate interior angles? Are alternate interior angles always congruent? No, okay? These are not congruent unless we know that these 2 lines are parallel, okay? So that's why it's so important to say if parallel lines. If you just said alternate interior angles are always congruent, that's not a true statement. Vertical angles are always congruent, but alternate interior angles are not always congruent. Okay, do we now have 3 pieces on each triangle? Yep, so let's follow the path, right? And here's where, which way do I start? Where do I start at? If I started here, I would go side, angle, angle. Side, angle doesn't exist. So just flip the order. Start with the angle and go angle, angle, side does exist. So we're going to move this proof statement down here. Triangle HFG is congruent to triangle GKH because of angle, side. Okay, I can't stress this enough, guys. The only way to get good at proofs is to do them, okay? And there's going to be proofs on your test, guaranteed. Your test is a week away, okay? And over the next couple of days, we're going to do a lot of practice on proofs. But if you just sit here and don't do it, or you don't practice it on your homework problems, you're going to struggle on this test. I can guarantee you that 100%. Because this is something you have never done before. You don't have a lot of prior knowledge that you're going to be able to come back on and say, I remember doing this in Algebra 1. This is a piece of cake, okay? Some of the stuff we've done this year, you could probably do that, but not with proofs. Proofs is something that's completely new to you.